Dear friends, I myself, Dr. Bharat Parab, discussing the topic equivalent version of Euclid's fifth postulate. Okay, we'll recall the Euclid's fifth postulate and then discuss. Okay, we see that by implication, okay, reading it very carefully. Okay, no intersection of lines will take place. Got it? No intersection of lines will take place when the sum of the measure of interior angles, okay, going very slowly, when the sum of the measures of interior angles on the same side of the falling line is exactly 180. Got it? And the sum is 180, exactly 180, and which angles falling on the same side. Okay, same side. So there are several equivalent versions of this postulate. Okay, one of them is Playfair's axiom. This was given by Scottish mathematician John Playfair in 1729. Okay, this axiom states that, okay, now we'll go through this very carefully. For every line L, for every line L, and for every point P not lying on line L, this is a point P, this is not on this line L, okay, there exists a unique line M, there exists a unique line M, only one line, okay, passing through P, line M is passing through P and parallel to L, okay, that means from this point there is only one line which is parallel to this, okay. Now if you have another line intersecting this line M, then this this line also let them intersect at P. Then if this is parallel to L, this cannot be parallel, and this also cannot be parallel to this line L. There is only one line. Okay. So same thing is given here in another words. This statement can also be stated as two distinct intersecting lines, distinct this line and M, or this line and M. Okay, two distinct intersecting lines cannot be parallel to the same line. Only one line can be parallel if there is some other line which is intersecting that line. Okay, now then this cannot be parallel to this. There is only one line parallel to the line. Okay, that is the meaning of this. Okay, try to understand this, read it once again, and you will definitely follow this. Okay, a very important and very intelligent statement and the explanation. Go through this very carefully. Consider the following statement: there exists a pair of straight lines that are equidistant from one another everywhere. Okay, pair of straight lines that are equidistant everywhere from one another. Okay, is this statement a direct consequence of Euclid's fifth postulate? And we have to explain that. Okay, we know the Euclid's fifth postulate and whether this statement has any relation with this Euclid's fifth postulate. And as explanation here, we know by Playfair's axiom, which states that, see, what is the axiom? For every line L, for every line L, and for every point P not lying on the line L, this is point P which is not on L, there exists a unique line M, there is only one line M, okay, passing through P, passing through P and parallel to L, and parallel to L, okay. Now this is the Playfair's axiom, and we will have some expression here. The distance between the two lines is PR and QS. Look at this, PR, QS. This is the perpendicular distance between the lines. Okay, we generally measure the distance which is perpendicular segment on both the lines. Okay, so we will read it again. The distance between the two lines is PR and QS. PR and QS is the perpendicular distance between the lines. Okay, which is same at all the points on L and M. Okay, you choose any point on M and drop a perpendicular to M, and from M to L again perpendicular. Okay, that will be same. So all these distances will be same. This shows that two lines are parallel to each other. Okay, distance is same, the lines are parallel. And a second thing is, as the angles are 90, these are the angles. Okay, that is, if you consider this line, then this is 90, this is 90. So on a right hand side, the total is 180, so they will not meet. Then on a left hand side, total is 180 and they will not meet. That is what is said here. As the angles are 90, sum of the measures of angles one side is 180, this side and that side is 180. Hence, they are not going to meet on this side and also on this side. Okay. Hence, this statement has a direct consequence of Euclid's fifth postulate. Okay. So that is the explanation. Now go through this. Due to some discussion on Euclidean geometry, a new concept of geometry was put forward, which was denoted as non-Euclidean geometry. Okay. Now there is an example here, very simple example. Go through this. Let us consider the following example. Okay, just reading it. The Earth has lines running from pole to pole. We know that these are called longitudes. Okay, which are perpendicular to the equator, and hence the sum of the interior angles made by the interceptor equator to these lines are 180. What does this mean? That if this is a line passing from this pole to this pole, this makes an angle of 90 degree or intersect at 90 degree to the equator. Another line which passes from pole to pole also makes angle of 90 degree to the equator. Okay, let us consider this line and this line. This is 90, this is 90. Euclid says they will never meet, but in this case this doesn't happen. They meet at pole. Okay, that means Euclid geometry fails here. Okay, so see here, read it again. The Earth has lines running from pole to pole which are perpendicular to the equator. Okay, and hence a sum of the interior angles made by interceptor, that is this is interceptor now, equator to these lines is 180. Okay, still they meet at pole. They should not meet by Euclid geometry, but they still they meet at pole. This is where Euclid's postulate fails. Okay, that is for curved surface it fails. That means Euclid's geometry is valid only for plane surface. Okay. Now this discussion gave rise to the non-Euclidean geometry. Okay. Now solving exercise. Read this very carefully. Does Euclid's fifth postulate imply the existence of parallel lines? Explain. Okay. What it says is Euclid's fifth postulate implies the existence of parallel lines. Okay. Now go through this very carefully. especially this discussion. It's very easy. Okay, so you will see this answer. Euclid's fifth postulate states that if a straight line, if a straight line falling on two straight lines, that is L1 and L2, this straight line is falling on this and this, these two straight lines, L1 and L2. Okay, if a straight line falling on two straight lines makes the interior angles on the same side, interior angles A1, A2 on the same side of this, on the same side of it, taken together, that is added, okay, taken together, less than two right angles. That means if they added and if the addition is less than 180, then the two straight lines, then the two straight lines L1 and N2, if produced infinitely, okay, if produced infinitely, meet on that side, meet on that side, okay, which meet on that side on which the sum of the angle is less than two right angles. Okay, this is A1 and A2 is less than 180, then these two lines will meet on this side. Okay, that is what it means. Now, very good argument here and very good explanation. Okay, go through this. If A1 plus A2 is less than 180, A1 plus A2 is less than 180, then lines would meet. Okay, then lines would meet. And converse of this, so converse of this is if A1 and A2 is greater than or equal to 180, they will not meet. Okay, so if these are less than 180, they will meet. But in this case, see, it's greater than or equal to 180, they will not meet. Okay, therefore, we are taking out of these two conditions, we are taking only one condition. Therefore, A1 plus A2 is 180. We are dropping that greater than, some greater than 180. A1 plus A2 is 180. On one side, lines would not meet. Okay, but under this condition, other side will also have A1 plus A2 equal to 180. Got it? If this is less than 180, okay, no problem. But if on this side it's exactly 180, then on this side also that will be also 180. Addition will be also 180. Okay, that is what it means. If A1 plus A2 is equal to 180 on one side, the lines would not meet. Okay, but under this condition, other side would also have A1 plus A2 equal to 180, and lines would not meet on the other side as well. Okay, got it? This shows the existence of parallel lines. So the answer was yes, and this is the explanation. Okay, this is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of equivalent version of Euclid's fifth postulate in Euclidean geometry, let me know through comment section and I shall solve it. Thanking you. Good luck.